Alright, here we go. So today we're going to look at doing some of the same things we've done with square roots, another kind of radical function with cube roots, okay? So we're going to be simplifying them, we're going to be adding them, we're going to be dividing them, all that stuff. So let's start out by just thinking about cube roots the same way we did with square roots. When we did square roots, if you remember, we thought about the different square numbers that we could take outside of the square roots, right? So we started thinking about the numbers 4 and 9 and 16 and 25, etc. Miss Slade, do you want to close that up? So we started to think about those, and we even wrote them on the side of our paper or whatever. So I think we should think about the even cubic numbers now instead of squared numbers. So these are all numbers you should be very familiar with when doing algebra. So we can use our calculator to help us, but let's over here write down the cubic numbers. So what is 2 times 2 times 2?
8.
Hoping not for 6.
8.
2 times 2 is 4, times 2 is 8. That's the first cubic number we're going to be searching for to simplify stuff. So the next one's 3 times 3 times 3. What's 3 times 3?
27.
9 times 3 is going to be?
27.
27, exactly. How about 4? 4 times 4 is 16 times
64,
another 4.
64.
You might need your calculator, but you guys have it, 64. 5 times 5 is 25 times another 5. It's
125.
going to be $1.25. So these are the cubic numbers we're going to be using in our attempt to simplify cube roots, okay? So then we've also got, let's keep going a couple more. 6 times 6 times 6, you need our calculator for. Miss Newett said 216. 343 is 7 cubed. Let's go one more. 8 cubed. 8 times 8 times 8, or 64 times 8 is what? 512. So these numbers are numbers you should recognize. In Algebra 2, we use them quite extensively for a lot of different things. And you should just, when you see 343, be like, oh, it's 7 cubed. Now, you don't have to get that, but it makes things so much easier.
It's a pretty cool number, too.
Yeah, totally. So they're a little bit big. They're a little unfamiliar. That's why we're trying them right now. So we've got the cube root of 135. So the question is, guys, can any of those numbers go into 135? What do you think?
5 times 5. I think the 125.
125 is not going to work, though. Remember, they've got to divide in. I'm trying to divide them in, Richard. So 125 is definitely too close to 135. So will anything go into 135? Don't make this hard on yourself. Use your calculator to help you. So I want to do 135. Should we test 8? You guys think 8 goes in? It's possible. Who knows? If you know number 3, then no. But should we try 27? Yeah, let's try it. Totally worked. So in other words, 135 you can write as the cube root of what? 27 times 5. Why would you care to write it as the cube root of 27 times 5? Well, because the cube root of 27 is 3.
Yeah.
Cube root of 27 is 3, because 3 times 3 times 3 is 27. Leftovers. So that simplifies to 3 cube roots of 5. Same way we did square roots, we're just using a different root now. Okay, so let's try this guy. 448 is pretty big. 56, I bet we can try 56. Any of those go into 56? I bet we could do that one without our calculator.
8.
8 does, right? So this one is minus 5 cube roots of 8 times what is 56? 7. So that part we can do without our calculator. It's going to be minus 5. The cube root of 8 is 2. I'm going to write it in red for anything that pops out. And then 7 stays inside the cube root, not the square root. So that's going to be what? Minus 10 cube roots of 7? Now 448 is a big number. I don't know which number goes in. Let's just try some of them. Let's play with it. So 448 divided by, let's try some big ones. You want to try the big ones first. So like 216? Okay. Nope. I thought 216 was going to go in. 125 is not, right? 64? Maybe. There we go. So this guy is the cube root of 64 times what? 7. And the cube root of 64 we now know is?
No, sorry.
You've got your numbers up there in order.
4.
Cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4. And I realize that you guys have not thought about the cube root of 64 before. That's why I'm showing you now, so that it's not a shocker when you see it a lot in Algebra 2. So let's see, that's 4 cube roots of 7. That's all you can do with that. Can I put these terms together or not? Sometimes you can, sometimes you can't. We have the same kind of objects here. Yeah, we've got cube roots of 7. We've got 4 of them, and then we've got, take away 10 of them. If you have 4 minus 10 of something, it's negative 6 of that something. There you go. Okay, so variables we did with square roots. Let's do them with cube roots now. So let's see, we'll take this guy. I don't think there's any numbers here, so we're not going to need our calculator for a second. So let's see. When we did this with square roots, I think we broke the stuff down in terms of squares. If it's cube roots, we should break it down in terms of cubes. So how many cubes are going to go into 8? Well, 1, there's 3 of them, 3 of the x's, then times 3 more of the x's. How many more do we have left now? 2, so it's going to be times x squared. Now I can do this with the z's to the 25th, but it's going to go, you guys got me? So let's just try to do that abstractly in our head. And this one's already in terms of a number that goes into 3, so I'm going to leave it alone. You could write it twice if you wanted to. But let's see if you guys can do it without that, because it gets too messy otherwise. So, cube root of x cubed cancels. You get x. Cube root of that x cubed happens as another x. This guy doesn't cancel. He's stuck. He's leftovers. He's going to be stuck. So now, you can write out z to the 25th, like I said, but let's think about how many times it's going to cancel. What's the closest multiple of 3 to 25? 27 is close, I agree, but you don't have 27. You only have 25 to work with. 24 is close, too, isn't it? How many times does 3 go into 24? 8 times. So if you wrote this out, you'd have z cubed, z cubed, z cubed, z cubed 8 times, and how many leftovers? 1. So it's going to cancel how many times? 8 times, and there'll be 1 left over. And this is going to cancel perfectly, right? 3 and 6 are going to cancel perfectly. How many times is this quantity going to come out? Twice. So you're going to have x minus 7 squared, because it's going to cancel twice. Now we said there's some leftovers, right? So it's cube root of what that's left over? This came out, x squared is left over. And we said most of the z's canceled. How many were left over? We had 24. If you want to write it, you can write 24 and 1. There's 1 left over. And these all canceled and came outside. So that, if you write this as x squared, is the final answer. That's as simple as it gets. We took out as many cubes as we could. Anything that's cubed in a cube root cancels. Same idea as over here, except we were breaking the number down into a cubic number that canceled and came out, and this stuff was leftovers. It's the same concept. I think it's easier with variables. If you guys practice, you probably will too. Okay, so we've got that one. Let's do one more. So this one has all that stuff in it. 3 terms. I don't know if we can add them together or not. 648 is a big number. Let's test it. What do you guys want me to try to put into it? You said 216? You love 216, don't you? And you're right. Nice. So that's 216 times 3 x cubed. 375? Can anybody do that in their head without the calculator? Which one of these goes into 375? It's 125 times 3. Very nice. do it with your calculator too, it's cool. Pretty obvious to check that for 125, right? It's got a 5 on the end. 686, I don't know. I'm going to go to my calculator. 686, let's see. 343 maybe? Oh yeah, cool. Times 2. Okay, so there's a lot going on there. So anything that comes out, I'm going to write in red. Anything that stays in will stay black. So we've got an x. What's the cube root of 216? Remember, we wrote it that way because the cube root of 216 comes out as 6. Does this come out or stay in, the x cubed? It cancels out. It becomes another x. Is there anything left over there?
Only a 3.
The 3. So we've got cube root of 3. Very good. All right, so then over here we've got a 2 already outside. Cube root of 125 is going to be 5. Cube root of x to the 6 is going to cancel twice, so we'll have x squared outside. Any leftovers? There. We've got a leftover 3 again. And then this one, minus 5, there's an x outside, cube root of 343. Go back and look at your list, that comes out as 7. And I think these are stuck, or they're going to be coming out. Are they cubic or not? Clearly not. Clearly not, that's just x, just 1. So those are both stuck. Okay, let's simplify a bit. So I think I've got 6x squared. What'd you say, Richard?
Only the first two are the same.
Very nice. So he's already looking ahead. And Richard looked at the first two and said they're the same, they're like terms, the other one's not. These are x squared cube roots of 3. These are x cube roots of other stuff. So these go together. There are in fact 16 of the x squared cube roots of 3, and then there's the other stuff. That's as simple as this problem gets. Right there. Okay? So some of this stuff can look scary. If you focus on the fact that you're just trying to take out as many cubic numbers as you can and variables, trying to cancel out anything that's cubic, that's all there really is to it. Don't let it make you think it's more complex than that. I thought we'd look at a couple division problems too. Let me pause this.